Okay, and we will start. Yes, over here. Yesterday, we started discussing the heap and the heap sort. Okay, heap and heap sort. Hold on. But we didn't go to the coding part. Okay. And we also discussed the tree as it and the heap sort. Heap sort, okay. And regarding heap sort, you first need to build the tree, is it? So that's the first step is heapify. So you build the tree. The second step, we call it sift up. So you're going to do a removing, is it? The first item and then swap the last item and then adjust your tree again, is it? So that's regarding heap sort and heap tree. And also always keep this in mind, okay? This is a complete binary tree. And because it is a complete binary tree, is it? And over here, the version we discussed about the implementation is to use array, is it? And in Java, it's array list. Array list, is it? And because of complete binary tree, is it? That's a node K. Node K, as it can be identified by its subscript, as it, and then its relationship with its left child and right child. The index, okay, is 2k plus 1 and 2k plus 2, is it? So that's the relationship, okay? Then this is regarding the in array, okay, be careful in array, okay. And we also have the node relationship with its parent, is it? With its parent is k minus 1, is it? Divide by 2, then it's integer division, then you can get the parent's index. Parent node, okay? So because of this relationship, so the implementation, then when we do it in array or array list, we can see it's quite good, is it? Okay, so that's the general review, okay? And before we do that, so can you, or let's do this exercise, okay? So how about let me first go back to a whiteboard probably. Okay, so how about you help me to finish this? Suppose we have sequence of number 5, 15, 2, 25, 7, 17, 28, and 3. So this is just some random sequence of number, is it? And I would like you to apply heap sort to sort it in ascending order. Ascending order, is it? Then the first step, you need to build that mini heap tree. The mini heap tree is minimum number is at root node. At root node, is it? So how do we do that? How do we do that? Anyone has a recommendation for me? Or yeah, anyone try to help me to complete this? First, we needed to build the tree, get all of the numbers into the tree. And the tree needed to be a minimum heap tree. Minimum heap tree. How do we do that? So the first is the heap 5.
Shouldn't 2 be at the top of the tree then?
5, is it? Is it? Yeah, 5 is here. Then what? 15, what should I do? With 15. You recall 15?
So you put it on the left, right? But
yeah, on the left. Yeah, on the left. Is it? Okay, so here we have 5, is it? Then we have 15, is it? So sub 0, sub 1, is it? And then next what? 2, is it? 2. Don't worry, okay, this is not a binary search tree. Is it? When you add, you need to make it a complete binary tree. You add it to the right because that's the available one. You're supposed to add it at the very back. But is this a mini heap tree?
no.
No, if it is not, what should you do?
Switch nodes.
Yeah, you need to switch node with the parent node. Is it? Okay, so let me clear this, okay, because otherwise it's going to be really messy. It's not going to. So now, so how about let me pick a different color. Then you have 2 here. Is it 5 here? Okay. Hold on, let me get back. And then basically we draw over here. That's easy to understand. But on your array, what will you do? You need also change this. Is it swap this 2? So this is going to be 2. This is going to be 5. Is it? So don't forget about that. Okay. So I will clean this out. Okay, so we have 2 here and we have 5 here. Is it? And okay, we get this 3 number down. Then 25. 25, where should I let it go?
On the left of 15.
Yeah, so 25. Is it? 25. So sub 3. And then 7. Where should I
Right
add
of 15.
Yeah, 7. So 7 is here. Index
Then
4.
sorted. Sorted. Switch the nodes.
Switch, yes, very good. Okay, so we need to swap. Is it with its parent? So 7 should be here. 15 should be here. So we need to swap 7 and 15. Is it? 7 should go here and 15 should go here. Is it? Okay, so let me clear everything out. Hopefully I won't forget. Okay. Oh no, let me. So here, 7, is that? That's correct. Okay. Then let me. What is this? Is 15? Is it? Okay, 15. And I also need to clear the bottom here. Here is 15. No. Here is 15, and then here is 7. Here is 7. Is it? Okay, we also have 7 down. And then 17 we count. Where should we let 17 go?
On the left of 5.
Yes, very good. 17. There's 17 here. Okay, and then 20.
On the right of 5.
Yes, 20. So 5, 20, 6. Is it? Okay, then 8. 8.
Left of 25.
Very good. Yes. Is it sub 7? Is this okay? Is this a mini heap tree?
No, it's
No.
not. You need to
It's
swap 8 to 25.
Yes, very good. Okay, so we need to swap these two. So 8 here, 25 here. Is it? Then on your array, it's quite far away. Is it? Okay. So here is 8. Here is 25. So when we do the up, that's okay. As if 7 is the last then. Okay. So let me clear this part. Okay. Because otherwise it's going to impact our future. Help me to remember. Okay. 8 here. That 8 is here. 25 is here. Is that okay? And then let me here is 8. Is here 8? Am I correct?
Yes.
Yes. Here is 25. Yeah. Okay. And then next, let's see. 8 we are done. Is it? And then 3. Where should I put 3?
To the right of 8.
Oh.
Yes. Here is it. So sub 8. Oh, not sub 8. Oh yeah, sub 8. Oh no, not 8. 3. 3 is here. Is it? 3 is here. Is this okay? Is this a mini heap tree?
It is not.
It is not. Yes. So we need to. So who? If it is not, what should I do then?
First, you got to swap 3 and 8.
Yes, very good. So 3 and 8. Is it? So don't forget here. And 8 is here. 3 is here. Is it? Can I stop?
Now you need to swap 7 and 3.
Oh, yes, very good. So swap this two again. Is it? So 7 here, 3 here. Is it? So 3 should be moved here. Then 7 should be moved down here. Is it? Okay, so how about let us clear a little bit, okay, otherwise too messy. And please help me to remember, okay. Otherwise I will forget. Okay, here should be 7, is that 7? And then let me erase this part. And erase this one. And I need to go back. Here is 8. Here's 8. Okay. And then by I need to also remember here. 8 is here. Okay. 8 is here, and 7 is here. Seven is here, and then clear 3. Okay, now is this tree a mini heap tree? So
Yes.
this is, yes. So we complete the heap 5 part. Is it? So that part we finished. Now what it asks you to do is to sort. Is it? To do sort the very beginning step is to get the first number out, is it? So you get, this is the minimum number, the root node, is it? And so how about sorted? Okay, I will put it in here, sorted array. So 2, I'm going to add it here, is it? So what you're going to do is you're going to get rid of it, is it? And you bring the last one, 2 here, is it? Okay, so what you're going to do is you are going to bring 8 here and clear 8 out, is it? Okay, let me erase everything to make it more 8 here, okay. How about let's also clean here a little bit. So 8 is here, and so basically right now, what you need to worry is from the very beginning, is it to 25? This one, you don't need to worry, is it? So we shorten the sorting range by 1, is it by 1? Okay, and but is this a mini heap tree? After you bring the last to the first, it is not very clear, is it? So you need to rebalance it. And the rebalance generally is you need to move the smaller up, is it? So that's why we call this step shift up, is it? Shift up. So what should I do here? This is not balanced, is it? So 8, you need to compare 8 with the minimum of the 2 child, minimum of 2 children, 2 child nodes. Is it? 3 is the minimum. So you need to swap them. So 8 is here, 3 is here, is it? So you are going to swap these 2, 3 and 8. This 3 and 8. Okay, let me do some cleaning work. Okay, so that I will first copy that, because otherwise mess up. 3, 8. And then let me clear that out. And how about let me clear here also, okay. So 3 is here, 8 is here, okay. And then let me clear both out, okay. So now we get this, is it? And is this a mini heap tree? It's not, is it? 8 and 7. What should I do with 8 and 7?
Swap.
Yeah, so you need to swap, is it? So 8 is here, 7 is here, is it? And then in your array, you need to do the same thing. You bring 7 here, bring 8 here, is it? Okay, now is this balanced? Yeah, this is balanced, is it? So how about let's do some cleaning work, okay? So that we won't mess up with everything. Okay, and here is 7, here is 8. Here is 8, is it? Here is 7, okay. Now we need to do more cleaning. Okay, this is cleaned, is it? So now this tree is balanced. And this tree is a mini heap tree. What should we do next? If we want, we can remove the first one again, is it? So you remove 3, you add it to the sorted part. You remove it. And what? You need to bring the last one here. Is it 25 here? So I'm going to remove this. Bring 25 there. Is it bring 25 there? Okay, and then let me clean it a little bit, okay. 25 is here. 25 is here, is it? And we shorten the sorting range by another one, is it? And oh, so how about let me clean more? Clean more, okay. How about let me clean this a little bit? Then 25 is here. That 25 is here. But the question is this a mini heap tree? Clearly not. Is it what are we supposed to do next? If it is not.
Compare 7 with 25, and then 25 with 8.
Yeah. Oh, 25, compare 25 with what?
With 7?
No,
The
no.
Oh, minimum. Okay.
Yes. So which one?
5.
So yeah, so with 5, is it? So you need to bring 5 up. 25 here, is it? And what's the step? 5 and 25. So 5 is here, 25 is here. Is it? That's what when we write a code, is that you need to deal with the array, is that array. And then what? Is this okay? 25 then? You need to continue compare 25 with the minimum of the child. Is it? So 17 up, 25 down. Is it? So you need to bring 17 here and 25 here. Is it? Okay, so let me do some cleaning work. Okay, first I will draw this so that we won't mess up. 5, 17, 25, okay. And then let's erase. Okay, and here. Oh, sorry. I get that line out. That's not nice. This is here. Then 5 is here. Is that I'm correct? Is that? And let me do. I need to clean this one. I also need to clean this one. And then let's see. 17 is here. 25 is here. Okay, not. Let me clean off this. Oh, I completely mess up. Not easy to handle. So we have 5, 7, 17, 8. 8. After 8 is 15, is it? 15. Here we have 25. Okay. And we have this, is it? So now it's balanced. It's a mini heap tree, is it? After it's a mini heap tree, what should you do? You get this out and move it to the sorted part, is it? And what? And then you bring the last one, is it? to that location. So it's 20 is here. This is gone. This is gone. And then what? Then you need to do the same thing, is it? Because this is not a mini heap, is it? So you need to compare with its child. So this time you bring 7 up, bring 20 down, is it? And then compare with those two. So 8 is here, 20 is here, is it? So now you have this balance. So here, anyway, for the array part, it's similar. Each time you do swap, is it? And then you can have 7 here, is it? And then you need to bring, oh, not 20, you need to bring 25 up here, is it? After you bring 25, you need to swap again, is it? So 25, then 8, is it? And 25, bring it down, and you bring 20 up, is it? So now we have 8, 20, 17, 25, 15, is it? Like this, more clear, is it? And then same thing, you get 8 to the sorted part, is it? And then you need to bring 25 up, is it? You bring 20, oh, not 25, I'm sorry, 25. You need to bring 15 up, the last one, okay. Bring 15 up, and then this is already the smallest, so 15, is it? And after you bring, then you need to bring 25 up here, but it's involves swap, is it? So you need to get 17 there, 25 here. So now you have 17, is it? Up 17, then bring 25, then you swap with 20. So 20 is here, 25 is here. Then you have 20 and 25, is it? So the sequence is sorted, is it? Okay, so this is a general idea about, so we did go over step by step, okay, about the heap sort, okay. And then next, let's take a look at the coding, okay. So we already understand how the algorithm works. Now let's take a look. So here we implement our heap, okay. And also here I define a mini heap, okay. You can also do the maximum heap, okay. And because we said it's going to implement it using array, it's very efficient. So that's why in Java we use array list, okay. And for the constructor, basically it's an empty one. It's an empty one for this one, okay. For this, if you don't have any array passed, and if you want to build from some existing one, then I do the for each loop through the array, and I call the insert method. Okay, so this insert method is what we just did. Okay, going to add 1 by 1, is it? So let's take a look at the insert method. So for the insert method, if you recall, don't view it as just the tree. Okay, here we deal with that array, is it? So when you add, you always add it at the back, is it? Add at back. Basically, it's the tree. So suppose over here, all field, is it? Then this is the available one, is it? So you are going to add it here, is it? And it's here, it's just, you're just going to add at the back, is it? At the back. Okay, add it to the back, but then you also need to what? Then you need to do, it may involve compare and move it up, is it? To keep the mini heap. The mini heap, is it? How do we do that? Okay, we get the location, is it? So this is the location. The index, is it? Index. And the parent, is it? Parent here is the location minus 1 divided by 2, is it? So somewhere in the array, is it? And then you compare with the element, is it, with its parent, is it, with its parent. And if it is less than the parent, so this part is swap. You need to swap the parent with the child. Is it? After you swap, then you need to update. Is it? So you need to move your location index. So here is your location. Is it? Location you need to move. And then this is a new parent. Is a new parent, so you update it. And then what? Then do the same thing. Is it? Do the same until you reach the root node. Is it? So that's how we do it using array for the insert, and also at the same time adjust the tree. Okay. Okay, nothing too hard, is it? And for the heap sort, if you recall, basically it involves always remove the root node, is it? Always remove the root node and then adjust the tree. That's so sift up, okay? So what we do is the root is always at the beginning of your array, is at the beginning. And then this too is you're going to get rid of that item, is it? Get rid of the item. And you get the first item, is it? You set the first item to be that to be what? You are going to first set the first item to be the last item. Is it? So that's, so this is, so here is the last item, and here is the sub-zero, is it? And this is the step. You are going to assign the last item to the first item, is it? And then you can remove it. Is it? So that's why we say each time you shorten it by one, is it? Shorten by one. Okay, so we get to this step, then what, that's not the end, if you recall, is it? You then need to do the sift up. So the sift up is basically you compare your current node with the child node, is it? That's how we do it. So you get this is a node. That's the child node. Index, is it? Child node. And this is left and this is right, is it? And then what you need to do, it involves a loop, is it? Until it reaches the leaf node, is it? You need to keep checking, is it? Keep checking, okay. So that's the loop. And you also need to, whenever you compare with both child nodes, but the minimum one, is it? Minimum one. So that's why here we have this minimum. Initially we set it as a left, is it? We set it as a left. But if the right one is less than the left, you're going to update your minimum index to the right, is it? To the right. That's what this step does, okay? And after that, then you are going to just compare it with the child node, is it? So compare with child node, and you may need to swap, is it? And after you swap, you update the location, is it? Update the location. And at the same time, after you update, you need to update the child node. Child nodes, is it? And then you go back, is it? We do that to sift up, is it? And of course, it's moving down for the location, is it? For the locations, keep moving down, is it? Okay, so after this or everything is it, then you can just return the root node, and your tree then at the same time will be maintained as a minimum heap tree. Okay, after the remove, is it? And if you keep calling this remove and fill it with another array, then that array is going to be sorted. Okay, so that's the implementation, okay, regarding this heap sort. And what next one try to give us is we can also display the tree, okay, so we can run this program to take a look, have some feeling, okay. And if you take a closer look, so this is the original sequence of numbers, some random number my program can generate, is it? And this is a tree. This part is a tree, and then here is a heap sort result. Okay, heap sort result. And if you take a close look of this tree, is it? So this is level 0, and then level 1, level 2, and level 3. Is it a different level? And if you take a look, the close to the bottom, the space is not that large, is it? And it looks like the space is keep growing. Is it keep growing space? Is it? And it has more space. Is it? Because if you want to draw, you got to do something like this. Is it? So anyway, so this is how the tree is going to look like. Okay. And then let's take a look. How do we display the tree? Okay, display the tree. So over here, it indicates the start and ending index in the array, basically. Basically, this corresponding to the starting index and the ending index. Okay, for one level in the tree. Because over here we are going to draw level by level, but when you do the print, it print at the top, not at the bottom, is it? Okay, and this is the level length. Okay, this is a number of levels, and the number of levels you can find it, is it based on the number of items in your array, is it? So array size, is it? And you take a log and then you divide by log 2, okay? Then you can find, and you take an integer, that's the number of levels, okay? Okay, we know the number of levels, then you can start to do the drawing. But here to do the drawing, because it's start at the top, but when you build the space, everything concatenate, is it? So there is not a good way that you can just directly draw from the top and then go to the bottom, because you don't know like how many space, is it? How deep the tree is. At the very top, suppose this is 0, is it? And it's based on how deep the tree is, then how many space you need to leave it. Is it? You need to leave it. So anyway, so over here, basically, you're going to build a string, and that string going to be made up of a lot of space and then the number. Okay, and also multiple lines, okay, multiple lines. So like over here it shows, is it? Okay, so that's the idea. So what over here we are going to do is you're going to loop through that level by level, okay? And when I is 0, and it's going to do the display, is it? So let's see what that display level does. Okay, this display level, and it has parameter number of level and the current level. Is it current level at the very top is 0? Is it? And the starting and the ending is it index? Okay, ending index. And the starting and the ending index here is at 0 and 0. Is it 0 and 0? And here the skip is to remember how many space before the number. Is it, in this case, it's 0, and then how many more space you need to print out? Is it all 5? Is it? And then you may have 6. Then so it's so each time when you do print, it's a number plus the number of space associated with the number in that level. Is it? Okay, and the skip then it's based on the number of levels and your current level. Is it? When your current level is at top, this number is small, this number is large. Is it? So 2 to the power, is it? When it's at the top, then you have more space. Is it? So the calculated space is always 2 to the power minus 1 something. Is it? Okay, so when you have start and end, initially it's 0. Is it? So it's just going to loop once. Is it? Loop 1, but how many space? Depends on this skip. Is it? So you're going to print a lot of space, all of the space. Then you are going to print that specific number, is it, on the tree, is it? And then you need to print more space. Is it? That take care of that specific node and the left space and the right space associated with that specific node, is it? So that's take care of this display level, okay? And it depends on where it start, where it's end for the whole level, okay, for the whole level. Okay, so that's regarding that part, is it, that part? And you need to have it go to the next line, is it, go to the next line. Okay, and then you update the length of that specific level is based on the starting and ending index, is it? And then you update the start index and the end index, is it? And start index from the previous ending index, but the end index is based on what? The calculation, is it? And if it is the end of the array, is it? Oh, if you recall, is it, suppose over here, we have one more, okay. All of those, so excluding the bottom layer, is it? Bottom layer, the last item, all of the previous ones, they meet the condition of based on the level, the level length, the relationship, is it? Until the last item, it's the array size, is it? Otherwise, it has the relationship with its previous level also, is it, with the previous level also, and as well as the last ending, the last levels, the last item index, is it? So that's why when you do the update, if this one is less than, then you keep the previous, the ending one, and depend on the level length, is it? And then you can update. So that's regarding regarding the display part. Okay, regarding display part. So this is the heap tree. And then for the application, what I did is I create an empty heap, and I have an array, a sequence of numbers. So here I just use 10 numbers. Okay, I use some random number generate. Okay, generate, and I keep adding to that array. At the same time, I also insert. So I build the tree. So this part is heap 5. That's a heap 5. And then we display the original array. And then over here, we display the tree. Display the tree. And over here, we find the sorted result. So here I just keep a print out of the heap sort result. Okay, so that's all of the information regarding heap sort. Okay, and I think we